Hi everyone. Welcome to my YouTube channel. My name is Sunny Savita and I'm back with another exciting and important video. So guys, this is 13th video of this end-to-end LangGraph course, and inside this video we're gonna discuss about the corrective RAG. Yes guys. So from this video onwards, I'm going to start with a different agentic RAG. In order to that, first I will discuss about the corrective RAG, then I will discuss about the agentic RAG, then adaptive RAG, and then self reg. Okay, so 4 to 5 video I'll be recording with respect to this particular topic. And first of all, let me do one thing. Let me show you the syllabus. So guys, this is the entire syllabus of this LangGraph course. So inside the first slide I discuss all the fundamental concept related to the agents, as you know, if you're following to me. Then in the second slide, basically I discuss all the basic and the necessary concept of the LangGraph. Then in the third slide, guys, I covered up to this common agentic pattern. Now only two main concepts are remaining. The first one is the RAG with the LangGraph, like CRAG, ARAG, and self-RAG, whatever I told you just now. And the third one, the second one is multi-agentic system. So guys, after completing this two topic, we will be good, right? We'll be like good for creating any kind of application using the LangGraph, because this two concept is a very important concept. And I've seen on the other YouTube, many videos you will find out related to this multi-agent and all, but no one is giving you the in-depth understanding, and no one is giving you this type of understanding with respect to the LangGraph and all. So guys, if you want to understand the LangGraph, langchain, and this AI application building and all everything, so my channel, it might be one stop solution for all of you. And here inside the video section you might get all the videos. I created a different playlist also, so if you will go and check with the playlist section, you will be getting the playlist with respect to each and every topic whatever is required, and I'm trying to create many more playlists in the future. So yeah, without wasting a time, let's start with the topic. So first of all guys, let me explain you the problem statement, and then I will come to the coding. So I hope so you are familiar with the syllabus, you are familiar with the title of the video, you are familiar with the the content and all everything. So here guys, I written the problem statement on my blackboard itself. So first let's try to discuss about it, and then step by step, one by one, we'll try to implement it. So first of all, let me do one thing. Let me stop my video so that you can access the entire board. I hope so it is visible. Now here, see, what's the topic name? The topic name is like a very simple. It's a corrective rag. So let me write it down over here. Corrective rag. But before starting this corrective rag, we'll have to understand about the rag. So guys, this rag actually, I already covered so many videos on top of this rag. So inside this particular video, I will just give you the glimpse of it. And if you want to understand in detail, you can check out with my YouTube channel. Now, this is the architecture of the RAG. Now, what's the full form of the RAG? Tell me. Retrieval Augment Generation. So inside the RAG, there is a three stages. So the first stage is called the data ingestion. Means we gather the data from somewhere. We divide into the multiple chunks. We perform the embedding out of it, and then we store inside the database. So this particular process is called the data ingestion. Now, whenever user comes, so user, what it does, it asks any sort of a query, and here this query basically it convert into the embedding, and we perform the similarity search or semantic search. Okay, and then we retrieve the uh, rank result. So rank result, or you can say the re-rank result, both are fine. Okay, and this refined data, okay, this retrieved data actually we pass to the LLM along with what? Along with my query and the required prompt. So context, basically it is called the relevant data. Okay, prompt, basically I can give any sort of a prompt for generating the output according to my requirement, and query actually it's a actual question, and then finally we get the output. So inside this RAG, we have three stages. First is this data ingestion, second is the retrieval, and the third is the generation part. I hope so this architecture is clear, and it's a pretty straightforward architecture. Now, whenever we talk about the corrective RAG, okay, so what is the meaning of this corrective? So the corrective, basically, here what we are going to do, see, if my RAG is giving me a wrong answer, okay, so what we can do, we can correct that particular answer. We can correct that particular answer. So here the corrective basically it is representing to this knowledge correction. Okay. Now, how it is possible, how we are going to perform this knowledge correction and all, everything I will let you know. I have a architecture with me. Okay. So guys, here, this corrective RAG, basically we are going to implement using what? Using the LangGraph. Now, why I am choosing this LangGraph? So LangGraph, basically, see, it give you the flexibility. Yeah, so inside the LangGraph, what you can do, see, you can define the functions, okay, in the form of nodes, and you can make a connectivity between these nodes, right? This is called edges. And guys, here you will find out one more thing, that we can loop. Okay, we can create a loop out of it. Means, let's say we are going from first node to the second node, and second node to the third node. Then again, if I want to come to the second node, again I can come over here, and then again I can go back to the third node. Okay, so this is called direct cyclic graph, which I already explained you. So this will help to us for creating this corrective RAG. Okay, this will help us to creating a corrective RAG. Means, let's say we are getting a wrong information using the RAG, I can correct that particular information. And inside my solution, from where actually I am going to correct my information? From the internet. Okay, from the internet. If my RAG is not giving me any correct answer, what I will do, I will fetch the data from the internet, and based on that I will be generating my final output. I hope so you got some sort of an idea over here, but let me give you the comprehensive idea. So over here, guys, you can see this is the architecture of the corrective RAG. Okay, now let's try to understand about this corrective RAG, like how it is working. So inside the corrective RAG, see what is happening, and this architecture basically we have defined, or we have created using the LangGraph, and the same architecture we are going to implement. Okay, in some time I will show you the code and all, everything. So we have a question, guys. So whatever question my user is asking, it will go to the retrieval node. Okay, it will retrieve the relevant document. Now my grader node, actually it is checking. Okay, this grade node, actually it is checking whether my relevant document is correct. Okay, or it is not correct. Means yes means correct, no means not correct. Okay, so guys, let's say I'm giving my document to the grader node. So if there is not any irrelevant document, means everything is fine. So what I will do, I will go to this particular condition, and finally I will be generating my answer. Understood? Okay, now guys, let's say if my document is an irrelevant document, means my document is not correct. So in that case, I will come to this particular side, and I will be rewriting my query. So again, I will be defining one node for that. I'll be rewriting my query, and then based on that I will perform the web search. Okay, from the web, actually from the internet I will fetch the information, and based on that we are going to generate an answer. So here, guys, this web search is nothing, it is a way. Okay, it is a way for correcting the information. So how we are going to correct the information? If my retriever, actually after the data ingestion, the retriever, whatever retriever I am going to create, okay, if this retriever is not able to answer for anything, if this retriever is not able to answer anything, so what I will do, I will be going through the web, and from this web, actually we are going to fetch the correct answer, and then we are generating the final answer. Understood, guys? So in my case, in my scenario, in my solution, I kept this web. Okay, this web search. But guys, in your case, it could be anything. It could be any database. You can fetch the correct answer from the database. It could be any other knowledge base. Okay, wherever you kept the data over the cloud and all, somewhere, right? It could be any API, specific API. You can define any sort of a logic. Understood? So this is the complete architecture of the corrective RAG. Now again, let me give you the like revision of it. So this is the implementation of the LangGraph, which we are going to implement. As I told you guys, we are going to start with a question. So here I created a retriever node. This retriever node, actually it is going to keep the retriever. Okay, retriever basically which we are going to create from the vector database. Understood? I will be writing the entire code over here, don't worry. Then grade document, we are going to grade our document whether my document is correct or not, means yes or no. Okay, then basically after this yes or no, let's say my document is the correct document. What I will do, I will be going to this generate node, and finally I'm generating my answer, and I'm giving the output. Understood? But let's say my grade, okay, is no, means I'm saying this document, actually it's an irrelevant document. Whatever document I'm going to capture now, so it's an irrelevant document. In that case, what I will do, if it is an irrelevant document, again I will transform my query, whatever query I was asking, and then I will perform the web search, and from the web search I will be fetching the relevant data, and then only I'm going to generate my final answer. I hope so, guys. This architecture is clear to all of you. Now, if it is not clear, again, we'll try to understand it. Now, what is the crux of it? So the crux is very simple. This grade document. If my relevant document is correct, okay, if my relevant document is correct, then I will directly generate the answer. If my relevant document is not correct, then I will take this approach. I will transform the query, I will perform the web search, and then I will generate the answer from the web itself. I hope so this architecture is clear to all of you. Now, guys, whenever we are talking about this corrective rag, okay, so here, guys, this corrective rag actually it's the implementation of the research paper. So if you will go and check with the Google itself, so just try to search about the corrective rag research paper. So you will find out this particular research paper, right? So here you will find out the complete detail, like how how people have implemented it, and it's a recent research. So see, when they have published this research paper in the October itself, last month only. And here, this research paper actually it is having a lots of potential. And see, guys, this is the complete algorithm of it. So this is the complete algorithm which we are going to implement in a simplest way. The architecture which I shown you, it's a implementation of this entire algorithm. If you have a time, you can read it. Now there are like couple of more headings you can check. So how basically they are going to basically they are going to rectify the information, see, using the web search. So inside the main research paper, they have used the web search. That's why like most of the solution you will be find out around the web search. But guys, it could be anything. I hope so. This thing is clear to all of you. Now let's come to the implementation, guys. So for practical, guys, I'm going to create a file inside the same folder. So like here you can see I created one folder, different type of rag with a LangGraph. So inside this particular folder, I created this corrective rag.ipynb, and this file you will get it over the GitHub itself. Now, guys, see, I already written a code in a refined manner. Okay, I written it by myself. I haven't copy and pasted from somewhere else. So I'll be copying and pasting over here inside this file. Okay, the chunk of the code, and I will more focus to explain the concept. Understood? So don't think that I'm going to copy and paste from somewhere. No, it's my code. I written it for all of you, and I'm not typing it because it's a time taking or I might do mistake and all. So I'm just like a copy and pasting from a notepad, and I'll be keeping it over here. And in the upcoming future, I'll be creating a modular code and all. And one more thing I would like to say, the functionalities, right? So different function I will have to implement over here as I like shown you. So yes, the code is going to be little lengthier. Okay, great. Now, so here first of all we have to load the model, and this time we are going to use the Gemini. So I loaded the Gemini model, and just a second, let me keep it over here. So yeah, loading the model, a very simple command. So loading the model. Great, guys. So let me load the model, and here after loading the model, what I'm going to do here, I'm going to simply check it. So for checking the model, here is the code. So let me keep it over here, this one. See, I'm going to check the code, and yes, it is working fine. Great. Yeah, it is great. Now, I written the question, write a bold about langchain. Okay, you can test it out with any sort of a question. I don't have any issue. Now, the next thing, what it is going to be. So here, I will create a retriever now. Okay, means I will perform the data ingestion. I will keep my data inside the vector database, and I will perform the similarity search on top of it. And based on that, I will be finding out the relevant document. So here I am going to make a heading. So the heading is going to be very simple. So here is what? Here is my retriever. Okay. Now this is the complete code, guys, for the rag. And again, I'm saying this rag actually I cover extensively on my YouTube channel. Let me show you that playlist as well, where actually I capped the complete playlist. Just a second. So here I'm going to copy and paste this code. Okay, this is the rag code. Now, after creating this retriever, what I will do, see, after creating a retriever, I'll be creating a rag chain. Okay, again, I'm saying, guys, this entire code has been written by me along with all the comments and all just before the class. I finished it, and here I am going to copy and paste just to save the time only. Now, what I have this particular code. So just a second, and I will explain you that part. Don't worry. And here the next thing is going to be I'm just going to like a testing the chain. Okay, so this is the testing, and finally it's my testing code. Understood? So on top of this RAG itself, I'll be performing the corrective RAG using the LangGraph. So now see guys, this is the complete RAG pipeline which I have created. If you'll go my YouTube channel, you will find out so many playlists on top of the RAG. Here see, inside the playlist section, we have this advanced RAG and this multimodal RAG. I have this complete RAG, okay, retrieval augment generation. So please try to cover the RAG from this playlist itself, and it will give you the comprehensive understanding of the RAG. Okay, now coming to the next part. So guys, here is my complete RAG pipeline. Now let me explain you this part. Here is what? Here is my statement, the import statement. This is my URL. From here, basically, we are going to collect the data. So I collected the data. Let me show you what we have inside this URL. So if you will go and check, if you'll copy and paste one URL, and if you'll paste it over the browser, so see, this is the blog actually. Okay, it's a blog post. So you will find it out over this particular link, right? So there are different blog posts. I capped 3 blog posts, and it is going to capture the entire text from here. Okay, it is related to the RAG and all, this agentic RAG. So I'm going to keep the same one. Now here see what I have this data. I am going to like fetch the data using this BAP based loader. Then here I'm going to make a chunking. Then here I'm going to store. So this is the entire chunking code. Okay, there's a chunk size and all everything, and here I'm going to store inside the chroma db. And finally I'm going to create a retriever from the vector database. Sorry, I am going to create a retriever on top of the vector database. Okay, this one. Now let me create a retriever. Now if I want to check, so for checking guys, here is a complete pipeline. Here is a complete chain. So this is my prompt. Okay, here I kept my prompt. This is my LLM. Okay, I kept my LLM, my Google Gemini LLM, and this is my output parser. So whatever like output I will be getting, I'm parsing using this output parser, and I will be getting my final string. Okay, so this already I explained you inside the langchain tutorial and all. You can go and check out. Now prompt wise, I will show you the prompt. So this particular prompt, we are passing only two things. So the first is a context. Okay, here you can see context, and the second is the question. So let me execute this part, and yes, this is well and good, and this is my prompt guys. So inside the prompt, context variable, context, and this question is my input variable, and you can read the complete prompt. So once you will right swipe, you will be able to read the entire prompt, this one. Okay, so based on this context, actually I have to answer for my final question, and this that whatever has been written, you can read it out from your end. Okay, and from where I am going to fetch this particular prompt, I am going to fetch it from the hub. Okay, so langchain is having one hub where actually they cap the entire prompt and all, and from there itself we are going to fetch the prompt, and this is my RAG chain now. So let me execute it and let me see whether it is working fine or not. So my question is very simple. Tell me about the agent memory, and yes, it is working very well. So I hope so this RAG chain is clear to all of you. Now let's create a corrective RAG on top of it. So for creating a corrective RAG, guys, let's create a skeleton of the code, and then we'll create a different function on top of it. So for creating a skeleton of the code, we required what? We required the LangGraph module. So here what I'm doing, I'm going to import this state graph from the LangGraph. See this one. And now what I'm doing, I'm going to define my state. Okay. So see, this is my state, and using this state, I'm going to define my workflow. Now you will be surprised over here, Sunny, why you are using all this thing inside this state, because so far we have just used the message. So guys, here the answer is very simple. I want to flow this all the values throughout the nodes. It's not basically the thumb rule. Always we have to define the message. I can define anything. So here you learn the new concept. Means I can flow anything throughout the node, and whenever it required, when from the state whatever thing is required, I can fetch those things. Understood? Great. Now let me do one thing. Let me create a workflow. Okay, so here's my workflow. Now let me create a different nodes. So guys, these are my different nodes. Here you can see retrieve, grade document, generation, transform query, and the web search. So this is going to my nodes, and I think so we haven't defined any sort of a function. It is giving me a error. Not an issue. We'll create the function and we'll look into it. We'll look into the the final output as well. Okay. Now this is my node, and here is my ages, guys. So just look into the ages also. So here I define the ages. So guys, see, this is my node: retrieve, grade document, generate, transform query, and web search. Understood? Now here is my edges. So first I will start from the retrieve, then I will pass it to the grade document. Okay. Now let's say if it is going to be pass, then what I will do, I will be generating the answer. See here I mentioned the conditional statement. If the grade document is going to be pass, means my all the document is a relevant document. In that case, simply I will return this generate, okay, and then finally generate to end. But let's say if this grader is giving me no, it is saying okay, your document is not a relevant one. In that case, what you will do, you will transform the query, you will pass it to the web search, and then web search basically it will fetch the output, and then finally you will be getting, finally actually you will be generating your answer, and then only you will get output. Understood? Okay. Now what I'm doing here, I'm going to compile my workflow. So let me compile this entire workflow, and finally I'll be displaying it. Okay. So see guys, this is my display. Now I think so this is completely fine to all of you. Now let's do one thing. Let's try to create a function step by step, because as I told you, inside the LangGraph, this each and every node is nothing, it's just a function. Okay, so let's create a different function step by step, one by one. So I'm going to mark it down over here. Let's create let's create a required functions. Okay, now here I will write a code, so there would be a like 4 to 5 function. So step by step, one by one, let me write all those function. And that's why guys I told you this code is going to be little lengthier because of this function itself. So the first function is going to be retriever. So this retriever actually what it will do, it will retrieve the relevant document based on the given question. Okay, see, this is my retriever function. Now the second function is going to be what, the grade document. So whatever I'm going to retrieve, okay, so just a second, let me do one thing, let me copy and paste it, because this might be little confusing, but don't worry, I will explain you everything. So here whatever document I am getting, so I will be grading those particular document. Understood? Now the third thing, basically generate. So if like let's say if the grader is saying yes, everything is perfect, no need to do the web search and all, in that case I will simply generate the answer from this particular method. Okay, now the next one basically is going to be transform the query. If basically grader is saying okay, your question is not relevant to the generated document, your question is not relevant to the generated document, in that case I will be transforming my query. Understood? Then guys, what I will do, see here, I will transform the query. After that I will be fetching the information from web, and from web guys I'm going to use the tably over here. Okay, so for web I'm using the tably, and let me define the tably, and I'll be fetching the web related I will be fetching the information from the web. Okay, and then here is what, here's my web search. Got it guys? So this is going to be my web search. Just a second, let me keep that functionality also. And guys, see, this code step by step, one by one, I created for all of you. So don't think that I'm just copy and pasting from somewhere, because I created and I executing in a precise way just to explain you. Okay, now web search is there, and then here one more method would be there, and this method is going to be very important, which will help to the conditional statement, that is decide to generate. Understood? I hope so you got it. Now in between you will find out couple of this lines. Okay, this yellow lines, it is saying query rewriter is not there, and here you will find out one more, retrieval grader is not there. Okay, and here basically this two thing I have to define like this rag flow. So let's try to define this query grader. I will grade the query whether it's correct or not, based on the relevant document. And then the third one, query rewriter. Okay, so here what I'm doing, let me create a couple of more line over here, and here the next thing is going to be query grader. Okay, so I written the query grader also. Just a second, let me give you that code as well, and then one by one, step by step, I will explain you each and everything. So here is my query grader guys, this one. Now let's try to create a query grader, and document grader based on the given query. Okay, now here is what, here is my basically class. This is my pydantic object. Okay, and what I'm doing, I'm passing this pydantic object to my model itself. Okay, so based on the given query, basically given query in this document, it's going to be great whether this thing is relevant or not. Means whatever question I'm passing, it is relevant to this document or not. Okay, now here if I want to test it, so this is my simple code for testing the document, sorry, testing this grader. Okay, this document grader, whether my grader is whether my document is correct or not, means whether my this document basically it is matching with the question or not. Okay, simply I'm checking. Now what I'm doing here, so here I'm executing it, and yes, we are able to create a identity class. Now here is what, here is my LLM. Okay, and this complete pipeline, right, retrieval grader, and here I'm just checking whether it is working fine or not. So this is my query, and here is my relevant document, and once I will invoke this chain, simply it will be checking whether this document, whatever is coming, it is relevant to this query or not. Okay, so here I'm executing it, and see here what I'll be getting yes or no. So see, binary score means yes. So what's the meaning of it? So the meaning is very, very simple. Whatever document is coming, relevant document, it is matching with my query. Okay, because here I'm asking the question related to what? Related to the agent memory, and which is already there inside the block. Okay, now let me ask any other question. So here I'm asking, tell me about the Taj Mahal. So the Taj Mahal, tell me, it is related to this basically this agent topic. No, let's see what I'll be getting over here. So if I'm going to execute this one, now you will find out the output. Binary score no, means this relevant, this document which I'm fetching now, it is not related to this particular question. Understood, guys? Tell me yes or no. I think yes, it is very simple. Now what I'm doing, I'm going to do one more thing over here. So grader is ready, and here is my rag pipeline is ready. Now let me check whether something is remaining or not. So one more thing is remaining over here, query rewriter. So I'm going to define the query rewriter also. So it will rewrite the query, means like let's say I written the query which is not matching with the document. So what I will do, I will pass those relevant document, and I will give this question. Okay, and I will say, okay, please transform this query. Let me show you how it will be working. So here is what, here is my complete code. Don't worry, I will explain you each and everything. And then this is my tester, so I can test it over here itself. So this is my testing function. Now here what I'm doing, I'm passing this prompt template, and you can read this prompt and all everything. I'm saying rewrite the query and use this LLM. Okay, and based on that, basically we are going to rewrite the query. So here we can provide few more information, means we can provide the document and all, and based on that we can rewrite the query. But here I'm using a simple prompt, and I'm just showing you how to rewrite the query. Okay, how to transform the query. Now let me execute it and see. Here was what was my question? My question was the this one. Okay, tell me about the agent memory. So now what I'm doing, so I'm going to rewrite this particular query. If this is not relevant now, what I'll be doing, I'll be rewriting it. Okay, this is relevant, this is fine, but let's say if it is not relevant, this particular query with this document, I'll be rewriting this query, and then I will what I will do, tell me, I will be like fetching the information from the web. Understood, guys? Tell me yes or no. Okay, so I'm just giving you the example with this particular question. So just a second, let me execute it, and here you will be getting the rewrite query. So what is the agent memory inside the artificial intelligence? Means this was the query, and I given to this particular pipeline, and it has rewritten the query. Okay, but see guys, this is the binary score is yes, so I no need to change the query for this one. But if I'm giving any other query, let's say this one, which is not relevant to this document, so this query I need to transform. I'll be writing it according to my document. Okay, and from the web itself, I'll be fetching the information related to this query, and then I will give the final answer. Understood or not? Yes. So this is the complete code. Now, what I will do step by step, one by one. Again, I will give you the quick overview of it, and then finally we'll try to execute it, guys. So guys, after writing this entire code and all, I think so like you might be distracted. Okay, so let's try to revisit the architecture, and then step by step, one by one, we'll try to revise each and everything, and we'll look into the final output. And again, I'm saying this is very much important. Using this one, like you can create a production ready RAG as well. Okay, production grade architecture and all, because this will make sure to correct the information based on your query and all, and you can do like so many changes inside this architecture. Or what you can do, you can keep the same architecture, and the query fetching, the document rewriting and all, you can modify it according to your requirement. Understood? Now see, So this was my architecture. Here is the architecture. Let's look into it quickly, and finally we'll try to run it. We'll try to execute it. I will just take 5 or 10 minutes of time, and we'll wrap up this session. Okay. So here guys, I'm going to start my execution. I will pass my question. This question will go to the retriever. Retriever basically it's nothing. I created on top of the vector DB after the data ingestion process. Okay. Then I will retrieve my relevant document. Let's say I'm asking a question. Tell me about agents. So here is my document. It will retrieve the document. Okay, let's say it has retrieved 3 documents, 1, 2, and 3. So it will check the relevancy of this document. Okay, this grid. If all this document is related to the question, then it would say yes. Okay, this question is relevant. Yes. Then what it will do, it will go to the generate. And finally, I will be generating my final answer. Okay, inside this generate, actually, I capped the RAG pipeline only. I will show you that. RAG pipeline. I hope so. It is clear. Now let me do one thing. Let me write it down again. RAG pipeline. Okay. Then guys, let's say if it is not a relevant one, let's say this has generated 3 documents, 1, 2, 3. Now let's say this document actually it's not a relevant document. No. What I will do, I'll be taking this query. I will transform it using the LLM only. Here also we are using the LLM. Don't forget. LLM plus prompt. Okay. LLM plus prompt. Right over here prompt. And after rewriting this query, I will perform the web search. I will crawl the information from the web, and for that I'm using this tably. And then finally I'll be generating the answer. Now you can tweak this architecture. Means you can keep anything. Let's say here I'm transforming the query. But while I'm transforming the query, I'm just simply passing the prompt and LLM. Okay, I'm just transforming this particular query. But here you can do what you can do. You can transform the query based on this given document itself. Okay, you can pass this data. According to that, you can transform the query. You can fetch the information from the web and you can generate the answer. This could be the solution. Now here I'm using the web search. But let's say you don't want to use the web search. You want to use any database, any APIs or anything. You can do that also, right? So this is very simple. Now let's look into the code and finally we'll conclude this session. And again, I'm saying guys, if you are thinking like it's a repeated one or something, then you can watch it at 1.5x for the better experience. And I would always suggest you watch every video at 1.5x. Okay, so you will get the good experience from the video itself. And this is usually I do whenever I watch any YouTube video and all. Now, so guys, here is my model, as you know. Okay, just a second. Yeah, here's my model. Now after the model, basically I'm testing over here. This is perfectly fine. Now I'm creating a RAG over here. Okay, so I'm fetching the data from this particular blocks using this web loader. And here, this is my RAG pipeline, RAG chain using the LCL. Okay, and here is my, I'm invoking the RAG. I'm just testing it, whether it is working fine or not. Now here's my grader, document grader. So what it will do, see, here I created one class. This class actually it's a pydantic object because I'm using this base model from the pydantic only. Now I'm going to define this variable inside it, and this is the complete metadata of it. Okay, metadata of this particular variable. Understood? Now guys, I will pass this particular class to the LLM, this one, and I have created this new LLM, that is structure LLM grader. Now I will pass this particular prompt. Okay, now inside this prompt I define each and every information like this document, question and all, and based on that basically I'm going to check, okay, whether this document is whether this question is relevant to this document, whatever document I'm fetching from the database or not. Okay, if it is relevant it will give yes, if it is not relevant it will give no. Query rewriter, basically what I'm doing, so here's my system prompt, as you can see this one. Okay, I'm giving the system prompt, and now after that here is my rewriting prompt. Okay, the system prompt human, and here is my question. Now what I'm doing, I'm just going to rewrite my query. I'm just going to transform my query. After what, after if it is this like document is not relevant, then only I will be transforming my query. Then what I will do after that, guys, basically after transforming the query, I'll be retrieving the data from the web itself. Okay, so yeah, so here is my grade. Just a second, I define the further functionality inside the method itself. Okay, so this is my rewriter, query rewriter. Now this is my first method. This first method, what it is doing is taking the state. From this state, guys, whatever thing is required for this particular method, we are fetching those information only. So let me show you where is the state. So here, if you will check the state, so this is the state which I already defined. This one: question, generation, web search, document. So whatever thing is required for this particular method, we are going to fetch those specific thing. Okay. Now let me do one thing. Let me explain the retriever first. So this retriever, what it will do? See, this is the like just this one doc string. Okay, no need to like worry about it. And here is one simple print statement. That's it. Okay. Now here is what? Here is my question. I will fetch the data from the retriever. Okay, and then I'm going to retrieve the document and the question. Got it? This is my simple retriever. Now, grade document, what it will do? So here is what's again simple print statement. It will take a question, it will take a document. Okay. This is my filter document, and here I define one variable, web search no. Initially it is no. Then I'm taking each and every document and I'm checking. Okay, retrieval grader, I'm checking the score. If the score is yes, I'm saying okay, this document is correct. If it is no, what I'm saying, okay, here web search is required, and then I'm going to continue this particular process. Understood, guys? Yes or no? Tell me. So I hope so. This thing is also clear. So if any one document which is not going to be relate, in that case, what I will do, I will perform the web search. So by default, actually, we are fetching the three document. Na? So three time it will be checking from this document. So any one document is not relevant. In that case, I'm going to perform the web search. Now this is the generation code. It is very simple. So it will take question, document, and here it will invoke the rack pipeline at the end. Okay, this is the like node. This is the function which I will execute in the end. Okay. Now here's my transform query. So it will take a question, it will take a document, and it will execute this question rewriter. And finally, I'll be getting my transform query. Okay, this better question along with this document. Okay, this is not relevant document, and this is my question. I'm just going to be rephrase the query. That's it. Then here is my web crawler, and whenever guys we require the web like search, so it will take a question, it will take a document. Here I will invoke the question, and based on that I'll be getting the web result. And this web result basically I'm going to be append where, tell me, inside the document itself, and finally I'm going to return it. Understood? This thing is also clear. Great. This one. Now this is my like conditional function. So here, if web search is yes, then I will transform the query. Okay. If web search is no, I will simply generate it. Understood, guys? Tell me yes or no. So you can look into the architecture itself, the same thing I was telling to you. Here is what? Here is my grad document. If web search, okay, means if this grad document actually means if it is no, then it will transform the query. And if web search, okay, here, if I have to do the web search, okay, yes, I will definitely retrieve. I will definitely return this particular part, and finally I will generate an answer. Okay, so this is the entire flow. Here you can see, and I hope so this each and everything is clear to all of you. Now let me execute it one by one, and I will show you the final output. You can go through with this particular code which I have designed, and you can look into the final output. So here is my retriever, here is my get document, here is my generate, transform query, here is my web crawling, here is my web search, then decide to generate. Okay, and then here is my complete architecture. Now let me show you that this is my compile, and finally this is my architecture. Understood, guys? Okay. Now, once I will execute the query, you will get each and everything. So here is my query. Tell me about the agent memory. Okay, I'm passing it over here to the stream. And here, basically, I'm just going to be retrieve the node. Okay, to which all node actually it is going through. And at the end, I will be getting the final answer. So let me execute it. See, retrieve. Okay, document 11 is the question. Yes, document 11, relevant, relevant. 3 document was there, relevant. Okay, 4 document was there, relevant. Graded document. Okay, means I'm able to grade the document. Then finally, here you can see it is generating an answer. Now I'm going to execute one more query. Tell me about the agent memory. Okay, so I'm removing this particular question, and let me write the different question. tell me about the Taj Mahal. So this Taj Mahal actually it is not inside the document. Okay, so let's see what I'll be getting over here. Just a second. Yes. So this Taj Mahal actually it is not inside the document. So here I am going to execute it and see what I'll be getting. So it is retrieving document, document not relevant, not relevant, not relevant. Okay, and here you can see it is going to perform the web search, and finally I am getting my answer from the web itself. Okay, how like useful it is, very useful. I will show you one more approach, self-drag, which is like a very much powerful. Okay, that research paper is also available. I will show you now. Just try to track this code. So first is going to retrieve, node is retrieve. Okay, then it is checking the relevancy, the question is relevant or not. So yes, like you can see the grade and all everything, document relevant. Okay, it's a graded document. Then it is trying to take a decision. Okay, it will generate it. Now node, which node? This grade document. Okay, this one is coming from everything over here, from here itself, and then finally generating. Now just try to track this question. See here, retrieve, I'm retrieving. Then here is what? Not relevant, not relevant, not related. Decision is what? All document are not relevant to question, transform the query. What I will do, I will be transforming the query. Then I will be going to the web search. Here I will be generating. Here I will be generating the answer, and then this is my answer. You can see into the conditional statement also. Let me show you this one. So retrieve, grade document, then grade document. Here what it will do, it will go to the, either it will go to the transform query or it will go to the generate. Okay, now see this one. So here is my question, and here is what? Sorry, here is my question, guys. This one, and this is my document. This is my web search, right? Now, if web search is yes, so what I will do, I will return this transform query. Okay, I have to transform the query because I'm checking now whether there is a web search or not. From where actually I'm getting this web search? I'm getting this web search from here itself. Okay, automatically it will keep the web search inside this particular variable. See, this one. Okay, while it is going to be checking the grade. So based on that, we can take a decision. Now, I hope so. This is perfectly fine. So yeah, please try to do it from your end. And if you have any doubt, any query, you can mention in the comment section. And yeah, thank you. Bye bye. Take care. I will meet you in the next video. Thank you.